Hello, everyone, and welcome to Lecture 2, technically, of Introduction to Philosophy. Today, we will be discussing logic, and in particular, we're going to be building off Joe Feinberg's A Logical Lesson, which hopefully you had a chance to read. If you had not had a chance to read it, please pause the video now and go read it first, as I am going to be assuming that you have at least given it a proper try to read it. Now, if you have read it, then you would have noticed that it can be a little tedious. And I promise that this is the only article that one can arguably say is tedious because it introduces a lot of distinctions and concepts. And it doesn't really defend a particular philosophical or interesting thesis. All of the other papers that we will read in this class will be defending interesting theses about whether we have free will, what does it mean to perform the morally right action, or questions about punishment, questions about consciousness. This one is the only article or unit in which no particular interesting idea is presented. And the main reason is because for this class, for this unit, we want to introduce certain tools that would help us to think more clearly when we discuss the other topics. So with that in mind, let's jump straight into the lesson. All right. And this is perhaps a good opportunity for me to mention this. So again, for the lectures, I'm going to be drawing heavily on the particular reading, which is why it's important for you to read it. But the content of the lectures are not exhausted by the content of the reading, which means that I am going to often introduce content that is not in the reading, either an argument or objection from another article in the literature, or maybe extra examples to exemplify some of its main theses. And the reason why I'm emphasizing this is because those extra aspects that I bring into the lecture will most likely show up on the weekly quiz that you would have to take at the end of the week. And so that's another reason why it's very important for you to do well on the quiz that you watch the lecture. And again, I'm going to try to make it as lively as I can and concise as I possibly can. That way, I'm gonna try not to be long-winded in my formulation of the main arguments, and I'm trying to make it as interactive as I can, given that it's an asynchronous class. All right, so let's get started. So this is probably one of the examples of introducing ideas or concepts that are not necessarily in the reading, but that I think will help us make the content of the reading more digestible. So the first thing that I want to introduce is the idea of a statement. And this is an idea that, again, we will be using for the remainder of the course. So it's very important that we get a good understanding about what a statement is. So a statement is a sentence, i.e. a set of words, that is used to make a claim that is capable of being true or false. So what are some examples? Just maybe pause the video and think about what are some examples of a sentence that makes a claim that's capable of being true or false. If you've thought about it, then maybe you can say something like the sky is blue, because the statement or the sentence, the sky is blue, is capable of being true or false. Notice that the key is not necessarily that it's true. So don't think that statements are facts. For example, I can say the statement, Daniel is 6 feet tall. That statement is capable of being true or false. In this case, it's false. I am not 6 feet tall. So it's a statement statements are false, or sentences that are capable of being true or false are also just statements. Okay? Now, what are sentences that are not statements? That is, what are some sentences that are not capable of being true or false. And again, maybe pause the video and maybe think about this for a second. What is a sentence that is not capable of being true or false? Okay, if you thought about it, maybe you correctly thought questions like, are you awake? That is a sentence, but it's not the type of sentence that is capable of being true or false, right? If I were to ask you, are you awake? You cannot reply to me and say, that's false, teacher. That's just not the kind of sentence for which the question of truth arises. What are some other sentences that are not statements, that is, that are not capable of being true or false? Again, if you think about it, yeah, maybe you thought correctly that commands are also type of sentences that are not capable of being true or false. If I was to ask you or command you to wake up, you cannot properly respond saying that's false, because I'm not making a claim about the world, right? When one makes a claim about the world, that is, makes a statement, that's when the question of truth arises. Commands is a way for us to use language to make the world in a certain way. I want the world to be such that you're awake, or if I asked you, close the door, I'm asking that the world, for you to be the agent through which it's such that the door is open, right? Or if I'm asking you a question, then I'm making an inquiry about how the world is. Is the world such that you are awake? I'm not making a claim about how the world is. Okay? So statements are sentences that make a claim about how the world is. And therefore, they're capable of being true or false. Either the way I'm representing the world is as I describe it, or it's not. All right, let's continue. Having now specified what a statement is, we can now build a definition for this class, and all philosophy classes, quite frankly, of what an argument is, because we need the concept of a statement first, and then we can build up our definition of what an argument is going to be for this class. So an argument is a set of statements, so at least 2 statements, but it could be more, and we'll see examples. So an argument is a set of statements that claims that one or more of those statements, called the premises, support another of them, called the conclusion. So this is not mysterious. Let's make it very simple. So 2 statements, 1 and 2. One statement we call the premise, and the second statement we call the conclusion. And an argument is when the statement which we call the premise supports the statement that we call the conclusion. That is an argument. So let's look at an example. Oh, okay. Actually, first, but yeah, let's look at let's just think about an example. So Alan, premise 1, Alan is unhappy. Or sorry, premise 1 is Alan is broke. Okay, so he has no money. Conclusion, he's unhappy. 2 statements, one of them is Alan is broke. It's capable of being true or false, either he's broke or not. And the conclusion is he's unhappy. Again, capable of being true or false. Maybe he's unhappy, maybe he's not. And the claim here that makes this an argument is that the reason why he's unhappy is because he is broke. So that is when one makes an argument, one is making a claim about the relation between the premise and the conclusion. Now, this is where we'll start. Feinberg talks about this a little bit, but then he jumps straight into what we can call now 2 types of arguments: deductive arguments or inductive arguments. Deductive arguments, again, think about what we mean by an argument. Namely, there's at least one premise and at least one conclusion which the premise is supposed to support. So deductive arguments prove that the conclusion is true. Okay? Another way of saying this, which Feinberg says, is to say that if the premises are true, then the conclusion necessarily follows, or is necessarily true. Another way to make the exact same point about deductive arguments is that it's impossible for the premises to be true and the conclusion false. So let's look at an example. Premise 1, all humans are mortal. Okay. Premise 2, Socrates is a human. Therefore, Socrates is mortal. Now notice that if the premises are true, and in this case they are, right? All humans are mortal, that's true. Socrates is a human or was a human, right? Therefore Socrates is mortal. Notice that if the premises are true, the conclusion necessarily follows. It is necessarily true that Socrates is immortal. Another way of putting this, which we described in a previous slide, is that it's impossible for the premises to be true and the conclusion false. That is, it's impossible for it to be true that all humans are mortal and that Socrates is a human, and for it to be false that Socrates is not mortal. What makes this deductive argument is that the truth of the premises guarantee the truth of the conclusion. This is why deductive arguments are also conceptualized as truth preserving. You can think about this like an argument is a particular box with an input and an output, where the input is the premises and the output is the conclusion. And if the premises are true, right? If the input is true, then you will always get true conclusion. It's truth preserving in that sense. Now, as we will see in a second, not all deductive arguments need to have true premises, and as you saw from the reading. But before we do that, let's maybe contrast it with inductive arguments. So in this class, we will normally be concerned with deductive arguments because we're normally interested in the relations between different concepts. Inductive arguments, as Feinberg suggests, is more concerned with establishing certain correlations or causal relations in the world, right? Sometimes in certain inductive arguments will show up in the periphery of our papers, but we will normally be interested in deductive arguments. Nevertheless, it's important for us to understand what an inductive argument is, if only to contrast it with a deductive argument, which is what we're interested in. So an inductive argument, as Feinberg says, a genuine argument, but that are not deductive. Okay? And what makes them not deductive is that they don't guarantee the truth of the conclusion. Like, that is, the premises do not guarantee the truth of the conclusion. They just make the conclusion likely true if it's a good argument. They could be very weak inductive arguments. So let's look at an example of an inductive argument. Premise 1. Author has been a moderate social drinker for 20 years. Okay? Premise 2. No one has ever known him to get drunk. Okay? Premise 3. Therefore, he won't get drunk at the party tonight. Okay, so let me ask you guys. Is this a deductive argument or an inductive argument? Well, to answer that question, especially if it's a deductive argument, because if it's not deductive, then it's inductive, you should ask. You should always ask of an argument, is it possible for the premises to be true and the conclusion false? Or another way of putting it is, if the premises are true, is the conclusion false? Now again, this is where initially when we first introduce this concept, it can be tricky, because you might be inclined to think, yeah, Arthur has been a moderate social drinker for 20 years. That's a very long time. No one has ever known him to get drunk. Surely he won't get drunk at the party tonight. And in that sense, this argument, if I were to give it to you, would probably make it rational for you to believe that he won't get drunk at the party tonight. But, as Feinberg correctly says, deduction has nothing to do with the degree or the confidence that we assign to the likelihood of the conclusion given the premises. As a matter of fact, this is an inductive argument. That is, this is not a deductive argument. And why? Because it is possible for the premises to be true and the conclusion false. For example, it could be true that Arthur has been a moderate social drinker for 20 years. It could also be true that no one has ever known him to get drunk. But it's possible that he can get drunk tonight. That is, that the conclusion is false. Suppose that he finds out that his wife has been cheating on him this whole time, or that he's gone bankrupt over an action over which he had no control, and he gets drunk tonight. That's not inconceivable, right? And because it is not inconceivable, or rather because we conceive of the premises being true and the conclusion being false, then this is an invalid it's not a deductive argument. And maybe I should introduce this term now, which again Feinberg raises, which is we talk about deductive arguments, and we can also call them valid arguments. So deductive arguments are valid arguments, and then arguments that are not deductive we called invalid. So we're going to use that term in this class. And again, this reading / lecture may seem a little bit tedious because we're introducing all these terms, and again, it can be a little bit difficult at first, but that's just why it's important to do the reading and to think about this, because having these tools and distinctions in hand will pay off when we discuss all the other contents and articles in the remainder of the semester. All right, so and by the way, this is a good example. This example, right, does not show up in Feinberg's article, but this example most likely will show up in the quiz. And again, I bring up these examples because I think that they're better sometimes than the examples that are used in the article, or just for variety's sake, or to make an adjacent point. All right, so let's continue. So this, and again, just to make sure we're clear, it's not a deductive argument, it's an inductive argument, right? Because the premises could be true and the conclusion false. Now let's think about why then a deductive argument, why they work. Why is it that deductive arguments are truth preserving? So let's look at an example. All humans are mortal, right? We already went through this. It's true. Socrates is a human, therefore Socrates is mortal. The reason why this argument is truth preserving is because it's impossible for the premises to be true and the conclusion false, right? It's not possible for all humans to be mortal and for Socrates to be a human, but for Socrates to fail to be mortal. It just follows necessarily. And the reason is because this example has, so just let's contrast this with another example. Premise 1 of this other example is all mammals have wings. It's actually false, right? Because not all mammals have wings. For example, dolphins are mammals and they don't have wings, right? All reptiles are mammals. Also false, right? And I'll let y'all biology majors tell me why that's false. Snakes, I don't believe are mammals, right? But anyways, it's false. Therefore, all reptiles have wings. It's also false. And again, this is the idea, but here's the kicker. Is this a valid or an invalid argument, or a deductive or not, or inductive argument? That's I'm asking the same question. Remember, deductive arguments and valid arguments is the same idea, same concept, or inductive versus invalid is the same idea. So is this argument valid or invalid? again, whenever you're asking this, and you're going to ask this question of the arguments that we evaluate in the course of the semester, you have to ask, if the premises are true, does the conclusion follow? And in this case, it does. If it is true that all mammals have wings, we know it's false. But if we're not evaluating whether it's true or false, if the argument is, sorry, if all mammals have wings, if that's true, and if it is true that all reptiles are mammals, then it does necessarily follow that all reptiles have wings. And so you can have valid arguments whose premises are false or conclusion is false. This is an example of that. Remember what I said about valid arguments or deductive arguments. They're like a box that are truth preserving, but in order for them to be truth preserving, they have to have truth in the box. So the input has to be true, and if the input is true of the premises, then the conclusion will also be true. But in this case, if the input is false, like the premises are false, then you will also may have false premises. It's not going to guarantee it. It could be true or false. Now the question is, what makes valid arguments or deductive arguments truth preserving? And the answer is that they have a certain syntactic form, by which I mean this argument exemplifies the following, let's call it syllogism or inference rule. All A's are B's. Actually, one second, let me see. Yeah, you guys should be able to see my mouse. All A's are B's, so let mammals be A's and wings be B's. So all A's are B's, all mammals have wings, premise one. All C's are A's, let C's be reptiles, and we already said that mammals are A's, so all C's are A's. Therefore, all C's are B's. Any argument that has this structure, where you say that a certain class of objects are another class of objects, right? Like all mammals have wings, or all animals are mortal, and so on and so forth. All humans are mortal, right? As long as they have this form, they will be valid. Again, that does not mean, or that does not guarantee that it's a true argument. I mean, this is an example right here, right? But what it does mean is that if you put into this form an argument whose conclusions are true, it will guarantee you that the conclusion is also true. And I know this looks a little bit difficult, like all A's are B's, all C's are A's, so therefore all C's are B's. That's kind of like hard to visualize if just by reading the syntax. But in actuality, it's actually pretty easy. It's actually not that hard. This is saying that let A be green, B be blue, and C be red. All of this is saying is that all greens are blues, right? Because it's inside the blue box, it's a blue circle, right? So it's inside, it's contained. And all C's are A's. All reds are contained in the green, which follows that obviously the red is contained in the blue. That is, that C is contained in the blue. So visually, the Venn diagram, you guys probably may remember from high school, very simple. And it is this quasi-mathematical, more accurately logical relation or form that makes these arguments valid or deductive. We have discovered, logicians since the medieval times have discovered these syllogisms or inference rules that are truth preserving, and that whenever you put in true premises, it guarantees the conclusion. All right, let's continue then. So here's an example of an invalid example in which all the premises are true, and the conclusion is also true. So Chicago is north of Dallas. True. Premise 2, Feinberg is mortal. Also true. Therefore, all birds have wings. So again, all birds have wings is also true. But is this a valid or deductive argument or invalid argument? I think from now on, I'm going to just say invalid or valid. But remember that when I say valid, I mean deductive or truth preserving. And when I say invalid, I mean inductive. Is this a valid or an invalid argument? Well, this might appear tricky at first because you can go, it seems like Chicago's north of Dallas is true. That can't be false. Feinberg is mortal. That also cannot be false. And all birds have wings. It's almost also seems to be necessarily true, maybe, if by definition we mean birds have wings. And this is where it can be a little tricky. This is one of the more trickier examples. But as a matter of fact, there's nothing. Remember what I said about truth preservation and the syllogism, right? All A's are B's, all C's are A's. Notice that there's a connection between the first premise, and the second has A's, and then between the second premise and the conclusion, right? This is what's allowing it to do the work. In this example, you can see that there's nothing about Chicago, Dallas, Feinberg, mortal, birds, and wings. Like there's no overlap in concepts, right? That you would be able to assign A's or B's or anything for that matter. And so there's no formal rule that would guarantee this to be true. Another way of putting it this is that in principle, and this is possible, for Chicago to have been a city that was named in south of Texas. In principle, it's possible. And again, this can get a little tricky, but it's possible that actually Chicago's north of Texas is actually false. But the more important point actually is that even if it's true, it doesn't guarantee the truth of the conclusion. It's possible that all birds could have failed to have wings. Maybe they are actually. Again, biology majors, you guys maybe can tell me, but it's possible because nothing about Feinberg's mortality and nothing about Chicago's location, its relative location to Dallas, has any bearing on whether birds have wings or not. Okay, so this is one of the more trickier examples, but I hope that understanding it through the prism of the formal syllogisms or inference rules makes it easier to understand why it is that a certain kind of argument is valid and a certain kind of argument is not valid. Okay, now let's see. Okay, here's another example. If Bill Gates owned all the gold in Fort Knox, then he would be wealthy. True, because there's a lot of gold in Fort Knox, which would make anyone wealthy, right? Bill Gates does not own all the gold in Fort Knox, as far as we can tell, right? Presumably, no single individual owns the gold in Fort Knox. Therefore, Bill Gates is not wealthy, which is false because we know that Bill Gates is wealthy. And so again, this is an example in which the premises are true and the conclusion false. And therefore, it is an invalid argument. Okay, so I think we've gone through examples, but just to recap then. So truth concerns facts, right? When we're evaluating whether a premise is true, we're evaluating whether it's true or false. And with respect to the world, are you representing the world in the way that you say it is, right? When you say that all humans are mortal, are you saying a fact that is true or not, right? Is Chicago north of Dallas? Are you saying something true about the world? Is Chicago actually north of Dallas? Validity or deduction concerns logical form, the form of the way that the premises relate to the conclusion. Do the premises relate in such a way all A's are B's, all B's are C's, all A's are C's, let's say, in such a way that it guarantees the truth of the conclusion. Okay? All right. Here's one more term to introduce because, again, this is just part of the introduction to logic. Soundness. Soundness just means that we want a valid argument, but we don't just want any crappy argument, right? Remember the example about all of the mammals being reptiles or having wings, rather. Yes, all mammals have wings. That crappy argument that obviously I hope it wouldn't convince anyone, but it was valid. It had the structure of a valid argument, but its premises were really obviously false. So what we want in this class is soundness. Both the argument is valid, that is, it exemplifies a form that is truth preserving, and it has true premises. Okay, that's the goal or the ideal for all our classes. And the reason why this is useful to keep these conditions separately in our minds, because that would allow us to assess arguments, or two different ways to assess arguments when we discuss them in this class. One way is to assess them in terms of their truth or the truth of the premises. And we will see many examples of arguments in which the premises may or may not be plausible depending on your philosophical sensibilities. Maybe, although because we are doing philosophy, most of the arguments are valid, although I believe we have an example. Yes, we will have a few examples actually of arguments that are invalid, in which it doesn't matter whether the premises are true or false. The conclusion just doesn't follow. Okay? With respect to your papers, this is also important. You want to write valid, true premises. And again, we won't have to worry about the syllogisms of all B's or A's or whatever, but your arguments will most likely have conditional statements, which we'll discuss in a second. And so you will want them to be valid and for the premises to be true. Or in your paper, if perhaps you're criticizing someone's argument, then again, you want to make sure that your argument is properly articulating whether it fails in terms of having true premises or it fails as a valid argument. Okay. Conditional statements. So this is the main formal kind of statements that we're going to be talking about, by which I mean that these forms or these inferences are probably the ones that are going to come up more often in this class, and which we are going to be able to examine whether they're truth preserving or not. So let's maybe back up for a second. So just what is a conditional statement? And again, this is what is ideal. Hopefully everybody who's watching this, hopefully you were able to read the text, because otherwise I think a lot of what we've been discussing would be kind of hard to digest without having had some prior exposure. So hopefully this shows you that it's ideal that you do the reading so that you can follow along in the lecture. Conditional statements. This is a conditional statement. It has two components. If P, then Q. And we're going to call, or let me give an example first. So this is an example. If this airplane flies, then there is gas in its tank. Okay? Antecedent is the if part, and the consequent then is the then part. So in this case, the antecedent is P. Just ignore that for a second. So in the antecedent is P, or in this case, this airplane flies. So that's the antecedent. And the consequent is there is gas in its tank. Q. Okay, so if P, then Q, and obviously for every P and every Q, you can plug in different statements. You get all sorts of different conditionals. This statement is saying some things, or really saying two things, which are really two sides of the same coin. And that's the antecedent normally specifies what we call a sufficient condition. That is, that it's sufficient for the consequent. So this airplane flies is a sufficient condition for the fact that there is gas in its tank, right? If I were to tell you that plane is flying, I don't need to tell you anything else. You can infer necessarily that it has gas in its tank. So it suffices. It's sufficient. It's a sufficient condition of its flying that it has gas in its tank, right? Now, the consequent we called a necessary condition. It's necessary for the antecedent. So this is another way in which you can reason back from the consequent back to the antecedent. If I tell you there is gas in its tank, or sorry, actually, let me put it another way, which I think is clear. If I tell you there's no gas in that airplane's tank, what can you infer from that? That's right. It's not, then the airplane is not flying, right? I don't need to tell you that it's not flying. Just by telling you that there's no gas in its tank, because having gas in its tank is a necessary condition of the airplane flying. So there is the relation between the antecedent and the consequent. The antecedent is a sufficient condition. That means once you know the antecedent of a true conditional, then you know what follows, right? The airplane's flying, then I know that it has gas in its tank. It's having a tank is also a necessary condition of its flying, so that if it's not there, then if its gas is empty, then you know that it's not flying because it's a necessary condition. But here's the important part. If you know that the gas has gas in its tank, it's a necessary condition, but is it sufficient for the plane to fly? So think about it. We know it's necessary. It's necessary for the airplane to have gas in its tank for it to fly, but is it also sufficient for it to fly? Or is it sufficient for it to fly? And the answer is, yep, you're probably right. You probably thought about this, that it's not sufficient. You need other things for the airplane to fly. You need a pilot, right? You need passengers probably. I guess not, but you need a pilot. You need all sorts of other. The weather probably has to be good. If you want to get a little technical about maybe flying legally or something like that. But the engine has to be working, right? There are all these other necessary conditions for the airplane to fly. So there's the consequent only specifies a necessary condition, but not necessarily a sufficient condition. All right. This is another way to specify the same relation. So this is one way to formulate it. If P then Q, and we saw the example, this airplane flies, then there is gas in its tank. This way is another way to say the exact same thing, but it seems to highlight the necessary condition aspect. But it says the exact same thing. An airplane flies only if there's gas in its tank. So it's a necessary condition. This formulation just seems to put the if in the antecedent or sufficient condition. This one puts the if, but it's not just an if, it's only if, to highlight the necessary condition. All right. So now we're going to talk about valid deductive forms. These forms, and again, these are forms that preserve truth. Okay? And one of them we will call is modus ponens. And these are Latin terms because these were discovered, I believe, in the medieval times. So the first form is modus ponens. And what is this form? It says this, premise 1. If P, then Q. Premise 2, P. Therefore, Q. Modus ponens says that this rule of inference is truth preserving, meaning that no matter what you put in the P, as long as you're consistent, right? So make sure that the P, whatever the sentence statement you put in the P, it's also in the second sentence and Q and as well in the conclusion. You will have a valid argument. It will be truth preserving. So let's look at some examples. If it is raining, then the ground will be wet. So again, it is raining is P, the ground will be wet is Q. Premise 2, it is raining. Again, remember, modus ponens was if P then Q, 2 is P, therefore Q, right? So this one is if it is raining is P, then the ground will be wet is Q. It is raining, so that's P, therefore the ground is wet. And how do you know that this is the case, that this is valid? Remember our test. Is it possible for the premises to be true and the conclusion false? No. If it is true that it's raining, if it is true that if it is raining, then the ground will be wet, which seems true. If that conditional is true, and it's also true that it is raining, then it necessarily follows that the ground is wet. Okay? Here's another inference rule or deductive form that, and these deductive forms, as we will see just starting on Thursday, are going to be employed by arguments that are going to have really interesting conclusions. So that's what we're learning, these inferences or deductive forms now. And this one we call modus tollens. If P then Q, that's premise 1. So notice that the first premise is exactly the same as modus ponens. If P then Q, nothing different. But here's the difference. Not Q is premise 2. Therefore, not P. So from if P then Q, first premise, second premise, not Q, therefore not P. And again, this is a valid form. It preserves truth. Again, it could have false premises, but that doesn't matter for deduction. Remember? Let's look at an example. If the alarm is working, then it will ring when there is smoke. Again, the P part is the alarm is working. The Q part is it will ring when there is smoke. The alarm did not ring when there was smoke. So the consequent is false, right? This says that it will ring when there is smoke. The alarm did not ring when there was smoke. So the consequent is false. Remember, modus tollens says not Q. So the consequent has to be false. So what follows? So what follows from this, given the modus tollens? Maybe try to answer it in your mind or out loud. That's right. Therefore, the alarm is not working. Not P, right? If P then Q, not Q, therefore not P. If the alarm is working, then it will ring when there is smoke. The alarm did not ring when there is smoke. Therefore, the alarm is not working. And again, how do you know the modus tollens is truth preserving? Because we cannot come up with a counterexample, right? Like we can't come up with an interpretation in which, or a scenario in which the premises are true and the conclusion false, right? If it's the case that the alarm is working, then it will ring when there is smoke. Like if that's true, if that statement is true, which seems plausibly true, right? And it is the fact that the alarm did not ring when there was smoke, then it follows that the alarm is not working. Like there's just no, it's the form, right? If P, then Q, not Q. Therefore, P is truth preserving. Okay? All right. Logical fallacies. And in particular, we're going to talk about two of which are related to modus ponens and modus tollens in a way. One of them is called affirming the consequent. And the form of this fallacy goes like this. If P then Q, so remember, a fallacy is, or I guess for the purposes of our class, we'll call fallacy a inference that is not truth preserving, so it's not deductive. So affirming the consequent. First premise, so you do not want to follow this rule of inference because it's not truth preserving, it's invalid, but you want to be on the lookout for this type of inference, either in your readings or in real life. I'm sure that politicians make these fallacies all the time. So this is why it's important for us to be clear thinkers. So if P, then Q. It's premise one. The second premise is Q. Okay? Therefore, not P. This is a fallacy. This does not preserve truth. And again, how do we know that? How do you know that? Are you going to just take that on faith? No. Remember our test for validity or for deduction. If the premises are true, is it possible for the conclusion to be false? And in order for us to show that, we can come up with a counterexample. So let's think about counterexample of affirming the consequent. And let's use the example that we used before. If it is raining, then the ground will be wet. So that's if P then Q. Second premise, the ground is wet. So remember, we're doing affirming the consequent form. So remember that affirming the consequent, if P then Q, and then it affirms the Q, the consequent, right? It affirms the consequent. It says that the Q is true. So if P then Q, Q. From this being true, it says you can infer the truth of P. And that's what we're saying, no, you cannot do that. That's what makes this a fallacy. So if it is raining, then the ground will be wet. It's premise one. Premise two, the ground is wet. So affirming the consequent. Therefore, it is raining. So this is affirming the consequent. This is a fallacy. And so you can say, this is not truth preserving because we can think of a scenario in which the premises are true and the conclusion false, right? Maybe you can take a second to think about it. So think about, suppose it is true that if it is raining, the ground will be wet, which seems likely. And suppose that the ground is wet. Is there a scenario in which that's true, that is premise 1 and 2 is true, but the conclusion false? Think about it. Or pause the video and think about it. You guys probably thought about a counterexample, right? Maybe the ground is wet because somebody was watering the grass, right? So in that case, it is true that if it is raining, the ground will be wet. That conditional is true. It is true that the ground is wet, but it is false that it is raining. The ground is just wet because somebody was watering the grass and it got the ground wet. So we came up with a counterexample to this form, to this if P then Q, Q flip Q. That's how we know that this logical form is not truth preserving, because we can come up with counterexamples. All right, let's do denying the antecedent. Another fallacy. If P then Q, so again, so just notice for a second that modus ponens, the truth-preserving logical form of modus ponens, the truth-preserving logical form of modus tollens, also start with if P then Q, and also affirming the consequent, the fallacy that we just discussed, also starts, all of these that we're discussing start from the same first premise of just a conditional statement. And then we're asking, what can we infer from the conditional given truth or falsity of the antecedent or the consequent? This one says, if P then Q, not Q, therefore you can infer not P. But again, this is a fallacy, right? This is not the case. And again, how do we know? Well, let's come up with the counterexample. And let's think about the same one. If it is raining, then the ground will be wet. So same exact conditional. But now we're saying we're denying that the antecedent, right? We're saying it is not raining. Therefore, you can actually infer that the ground is not wet. So, again, let's think about a scenario that would make this not valid. That is that it shows that it's not valid, right? Because this is a fallacy. Is it possible for this premise to be true and the conclusion false? That's right. It's possible that the ground is wet. It's the same exact scenario as before. It's possible the ground is wet because somebody was watering the grass, right? So it's true that if it's raining, then the ground will be wet. It is true that it's not raining, but the ground is actually wet. So this is not truth preserving. All right, circular reasoning example. And maybe you have heard colloquially somebody say, maybe you guys have heard this phrase called beg the question. Have you ever, journalists seem to be very apt to say this. Oh, that begs the question. And then they ask a question. That's not the way that we're going to use beg the question in philosophy. By begging the question, we mean that somebody's engaging in circular reasoning. And by circular reasoning, we mean that they are assuming that which they're trying to prove. So if we think about an example between premise and conclusion, the conclusion is already in one of the premises. And so you're not actually inferring anything. You're assuming that it's already the fact. Okay, so let's talk about an example of this. Someone may say, we know God exists because the Bible said so. And you might say, okay, but how do I know that the Bible is true? Well, we know, and they will tell you, well, come on, we know the Bible is true because it is the Word of God. Okay, well, this is not a good argument. There are interesting and good arguments for God's existence, which we'll discuss in this class. This is not one of them, because this is not actually, I mean, it's an argument by our definition that it has a statement that supports the conclusion, but it's completely circular. So let's unpack this so we see why it is that it assumes what it sets out to prove. So what this argument is really saying is that God exists and he inspired the Bible. Premise 2, that Bible is God's word. The Bible says that God exists. Oop, my apologies for the typo. Therefore, God exists, right? It's trying to infer God's existence from the Bible saying that God exists. It's supporting the fact that the Bible says that God exists by saying that the Bible is God's word. But saying that the Bible is God's word is already to assume that he exists and that he inspired the Bible. So premise 1 here, God exists, that is the conclusion. It's just assuming. And this is what we call circular reasoning, and or what we will call in this class begging the question. This is also important for the perspective of when you write a paper. You want to avoid, and it can be tricky, because when we think about various things, and I've done this before, sometimes we don't realize that we're kind of assuming that which we're trying to prove. So very important that you don't do this in your papers. And again, thinking about it in terms of premises and conclusions is very helpful. By the way, on that note, when you write a paper, what is the thesis of your paper with respect to, and I'm jumping to now talking about your paper because this is the last slide that we'll talk about in this lecture. What is the thesis of your paper? That's right. The thesis of your paper is a conclusion. And the thesis of your paper, which is a conclusion, is different from the argument for that thesis. Right? And that's very important for you to just maintain in your mind, because you can have a thesis which seems plausible, but your argument for that thesis may not be very good. Or alternatively, you can have an interesting argument that's plausible, but it doesn't quite show is or doesn't quite support the thesis that you're trying to prove with that argument. Maybe it supports a different thesis, which is still interesting. And that's really important and good to understand. This is why logic and philosophy more broadly is going to help us be better thinkers and writers, because it allows us to think more clearly about reasons for supporting various beliefs and the degree to which those reasons actually support those beliefs. Okay? All right, so we'll end it there. And again, I know that the lecture was tedious. Thank you for hanging in there. Going forward, starting on Thursday's lecture, you will see that's going to be much more interesting, although maybe some of you found this interesting. It's definitely essential and very valuable. But on Thursday, we will discuss what makes a person's life good or bad, in the sense of like, how do we know that someone's life is actually good, like it's a good life, or is it a bad life? And we will consider the first answer to that, which is hedonism, that what constitutes a good life is a happy life. That's probably the more plausible way to formulate a thesis. But anyways, we will discuss that on Thursday.